Hello students, welcome to CBSE Science Series. Today we are going to learn about photoelectric effect. We already studied about electron emission and work function. I uploaded one video about electron emission and work function. If you didn't watch that, you please go and watch that. Electron emission is emission of electrons from the metal surface. We know that metals are the good conductors of electricity. It is because of the free electrons, but that free electrons never come out of the metal surface, because when the electrons come out of the metal surface becomes positively charged and the electron is negatively charged particle. So there will be attractive force between the metal surface and the electrons. So the electrons goes inside the metal surface. If the electron has a more amount of energy to break the attractive force of the metal surface, the electron can come out of the metal surface. That minimum amount of energy required by the electron to escape from the metal surface is called work function of the metal. And we denote work function by phi naught, and it is measured in electron volt, and the work function is different for different metals. This is what we studied about the electron emission and work function. Now, how can we supply this minimum amount of energy required by the electron to come out of the metal surface? There are three processes. One is the thermionic emission, field emission, and photoelectric emission. Thermionic emission means heating. We supply more heat. When we supply more heat, that is thermal energy, uh, the electrons absorb energy from the heat, and they come out of the metal surface. These electrons are known as the thermions because they come out of the metal surface by the heat. So these electrons are known as the thermions, and this process is known as the thermionic emission. In field emission, we apply the strong electric field up across the metal surface. When we apply the strong electric field across the metal surface, there will be repulsive force between the negative field and the electrons comes out of the metal surface. In photoelectric emission, the light is allowed to fall on the metal surface, and the electrons absorb energy from the light and they move out of the metal surface is known as the photoelectric emission. And these electrons are known as the photoelectrons. Because they are ejected by the light photo, so they are known as the photoelectrons. And this is what the important topic we are going to learn in this chapter. Now, who found this photoelectric emission? First, German physicist Heinrich Hertz found this photoelectric effect in 1887 when he was doing electromagnetic wave experiment. This electromagnetic wave experiment is about detecting the electromagnetic wave between the electrodes, and for that a strong electric field, that is high voltage, is applied across the electrodes, and this high voltage creates the spark across the electrodes, and the spark is enhanced when the emitter plate was illuminated by the ultraviolet light. This is what observed by the Hertz in 1887. It is because when the UV light falls on the emitter plate, the electrons move out of the emitter plate to the surroundings, so that the spark increased. So this is what photoelectric emission. And later this photoelectric emission studied by the Wilhelm Hallwachs and Philip Lenard in 1886-1902. They conducted experimental study about the photoelectric effect. Hallwachs connected a zinc plate to an electroscope, and he allowed the UV light to fall on the zinc plate. He observed that the zinc plate lost its charge after the falling of the UV light, and he also observed that the uncharged zinc plate becomes positively charged after falling of the UV light, and if the zinc plate is positively charged initially, and it becomes more positively charged after falling of the UV light. So from these experiments, he concluded that the negatively charged particles were emitted from the zinc plate when exposed to UV light. Means when the UV light falls on the zinc plate, the electrons in the zinc plate absorb energy from the UV light and they move out of the zinc plate. So That is why the zinc plate becomes positively charged. When the body loses electrons, it becomes positively charged. So this is what the reason why the zinc plate becomes positively charged after falling off the UV light. And Leonard also observed that when the UV light falls on the electrodes, the current flows in the circuit. For that, uh, he arranged the two electrodes in a evacuated glass tube. One electrode is known as the cathode, another electrode is known as the anode. When the UV light is allowed to fall on the cathode, the electrons in the cathode absorb energy from the UV light, and it comes out of the cathode and it starts to move towards the anode. Hence the current flows in the circuit. These electrons are known as the photoelectrons, and the current and the current is due to this photoelectrons. So this current is known as the photo current. This is what observed by the Leonard, and this cathode electrode is known as the emitter plate because it emits the electrons when the UV light falls on it, and the anode plate is known as the collector plate because it collects the photoelectrons. So this is what the experimental study conducted by the Leonard. When the UV radiations are stopped, the current also stops. These observations again tells that UV radiation incident on the emitter plate eject some negatively charged particles from it. So after the discovery of the electron by the J.J. Thomson, these negatively charged particles are known as the electrons, and these electrons which are ejected by the light are known as the photoelectrons. And Hallwachs and Lennartz also observed that if the frequency of the incident light is very low, no electrons were emitted. Means to eject the electrons, the incident light must have minimum value of the frequency. If the frequency is less than this minimum value, no electrons were emitted by the incident light. So this minimum value of frequency is known as the threshold frequency, and this threshold frequency is different for different metals. So this is what about the photoelectric emission. Now how can we define the photoelectric emission? The phenomenon of emission of electrons from a metal surface when electromagnetic radiations of sufficiently high frequency are incident on it, it is called photoelectric effect, and these electrons are known as the photoelectrons. This is what about the photoelectric emission. Thank you.